So there are a bunch of different versions of PCR, RT-PCR, QRT-PCRs, and whatnot. So this is just a clarification. So PCR is just polymerase chain reaction, and you just use DNA and then make bunch of them, make a lot of them. And what you can do afterward is you can use bunch of DNA to, you can do agarose gel electrophoresis. So that's this thing with the gel, and then you can see how far it goes down and see how you can compare with this agarose gel electrophoresis. You can compare the size of the DNA or the gene you're interested in. And sometimes in front of PCR, we have this like qPCR or RT-PCR or QRT-PCR. So what do they mean? So RT means reverse transcription. And what this means is that RT-PCR, for RT means they start, instead of starting with DNA, start with RNA or mRNA. So, and because transcription is going from DNA to RNA, reverse transcription would be going the other way, RNA to DNA. So reverse transcription means you start with RNA or mRNA. So once you have, for the RT-PCR, you will have RNA to start with, and then you will have to do RT, the reverse transcription, in order to make it into DNA, and then you can do follow the procedure of the PCR. So that's what RT means. Q means Q is for the quantification. So that is when you're using like a cyber, the green, the fluorophore, and you can use a cyber to measure its fluorescence, and the fluorescence, it's the light emitting capability, and we can make this beautiful graph of. And once we start for example, qPCR, we do the same thing. The only difference is that we put the cyber, the green fluorophore, when we're doing the amplification process. So with all the new DNAs that are newly made, will have a cyber attached to it that will make it glow. So once you increase the number of newly made DNA, it's gonna start to, we're gonna be able to notice the light from the cyber, and it will get brighter and brighter as we do more cycle of the amplification, because we're increasing the number of this newly made DNA, hence the activity of the cyber, the light emitting green fluorophore. And we can use this to measure. So it depends on where it starts. Like for example, if you have this threshold where we can actually see the light, and we can see for this one, let's say from like after the 20th cycle, it starts to, we're able to observe the light. And for here, where we started at 30, so we see that we'll be able to tell that this one had more DNA than the one over here. So using this the cyber, we are able to quantify the quantity of DNA. So that's what Q represents. And so if it's just qPCR, we are starting with DNA, and then we're gonna do the cyber so that we are able to quantify the amount of DNA present. If it's a QRT-PCR, then instead of DNA, we're gonna start with RNA, and then we're gonna change the RNA into DNA, and then follow the PCR procedure, except that we are also doing the quantification part, so we're including the cyber in it, so that we can quantify the amount of DNA. If it's qPCR, we already did that. And if it's just RT-PCR, we start with RNA, we do the PCR, and without the fluorophore, so it's not going to be glowing in the dark, but we can do agarose gel electrophoresis to figure out the length of the gene that we're interested in. So in essence, Q is for quantification, so it's about the light. Through light, we can quantify the amount of DNA. RT means it start with RNA instead of DNA. So, and just regular PCR, we start with DNA, and then most likely you'll do agarose gel electrophoresis. The CFAS cube, we're going to, instead of agarose gel electrophoresis, we're going to do the light graph. If it has RT in it, we're going to start with RNA instead of DNA.